Okay, so now we will talk about the densities in the solution. By this we mean that we have a mixture of different components and like the solution of water, ethyl alcohol and methyl alcohol. And we have components of different densities mixed together and we need to calculate the density of the solution. Um, we know the density is the mass divided by volume, and for a mixture the total density is gonna be the average density of the mixture, or the density of the mixture is gonna be the mass by the total mass by the total volume. And sometimes we are interested in getting a relation between the concentrations and the densities because we might not know the exact mass of each one of the components, so we would like to use the densities or calculate the densities as a function of the mole fractions or mass fractions. We know that for each component the mass is the volume multiplied by its density, and we know that the total mass is going to be the total mass of the components m1 plus m2 to reach the last component, and it's going to be the summation of mi, which is this, which is vi multiplied by rho I. So this is the total mass. So if we need to get the average density, it's gonna be this mass divided by the volume, and this is the mass and this is the volume. And if we divide the vi divided by the v, it's gonna be the small v, which is the volume fraction. So the average density is gonna be the summation of the vapor fraction or the volume fraction multiplied by the density of each specific component or single component. So this is a good relation that we can use to get the average density if we know the volume fraction of each one of the components. There is other way that we can use to calculate the average density, but in this case we are using the mass fraction, and this is kind of more applicable than the previous case. Um, uh, and by this we start with the volume is going to be the mass divided by the density, and the volume is going to be the summation of the total volumes. So it's kind of like the what we did here. We started by m and then the total m, but here we started with v, and this is the total v. It's going to be the summation of mi divided by rho I. This is the total volume, and the one of the over the density is going to be v divided by m, which is this v, which is this is the same as this divided by the total mass, and mi divided by the total m is the mass fraction. So you can say that the 1 over the density, the average density, is xi divided by rho I, which is the component mass fraction divided by the component density. The same thing we can apply to the molecular weight. This is the average molecular weight can be calculated from this equation. You can derive it by yourself. It's going to be simple. It's the mole fraction multiplied by the molecular weight, and one of the average molecular weight is going to be the mass fraction divided by the molecular weight. So these equations are again used to calculate the density of a mixture based on the molecular weights of the species in this mixture, and their mass fraction, their volume fraction, and we can use the mole fraction as well. You can do it by yourself as well. So these are like some useful equations that we can use in this case. So we have only one thing left, which is the basic chemical calculations, and I'll leave it for the last video in this chapter, inshallah. So I'll see you then. Goodbye.